joining us today. It's a pleasure kind of organizing this session. Thank you to Julio and Alejandro for their time and everyone for their time to join us today. The idea of this session is going to be an introduction for a few of the tools and packages that Python has for log analysis. We have Julio, and I am going to let him to introduce himself, who is going to show us some of the tools that we can use, basic concepts, and to get more familiar with this programming language. So that is going to be about 30 minutes, and after that we will have time for a few questions, and also if you feel comfortable to do it, to introduce yourself, everyone, and I don't know, comment something about your own projects or what you are interested in doing, or whatever you want to say that will be important to find collaborations or projects or whatever you want. Yeah, I think that with that, I don't know, Alejandro, you have something else to add before we go to Julio? Okay. This session is going to be recorded and posted in the YouTube channel later. So yes, you can go back and see the material. Perfect. Okay. I'm going to mute myself, and Julio, all yours.
Okay, thank you, Diana. Well, first of all, I want to thank you for the opportunity to see you guys virtually here today. And well, let me introduce a little bit about myself. I'm Julio Rodriguez. I am from Mexico. I live in Mexico right now. I'm a geophysicist. I do have a master on petroleum geoscience. And also I know a little bit about computer science. I have a question for you guys. I know Diana a little bit. Maybe she's into Python already or working on it. What about you guys? Do you have any previous experience? Do you know what is lasio, Welly, PetroPy? Any previous experience? You can chat right on the chat, or you can activate your microphone for a second and just talk about it. That will be good. Mm-hmm. All right. That's Alejandro. Somebody else wants to share a little bit? I don't know, John, Judith, Felix, Moody, Jamal. Something you want to say about it?
Yeah, don't be shy. Just for me, this is Diana. I use the PetroPy, kind of running the examples. I have seen lasio and Welly and some others, like Striblog or some other things, but yeah, I can say is basic for me.
Okay, well, guys, I was asking you to share a little bit, because well, I want to start talking about these libraries. Okay, well, sometimes if we want to check a last file, we will need some. Hey, John says I know lasio and lasio. Lasio is pretty cool, by the way. So sometimes when we want to check a last file, we will need either a software from a company, call it Halliburton, Schlumberger, Baker, whatever. And if we don't have it sometimes, and I know people that sometimes they use Excel to work with the last files. My dad is a petrophysicist, and sometimes he used to show me how to teach me, by the way. That's the correct word. Teach me how to do it on Excel, and that's okay, but that's a little bit slow if you want to see it this way. You can also open last files on a notepad, and you can see the header. You can check it, but if you want to create something extra from that, add another column, make some maths with the curves. That's not gonna work. That's not gonna happen because it's a notepad. It's difficult. So we have these three, and I think there are more, but the three main or the most popular so far is lasio, Welly, and PetroPy. Actually, Welly and PetroPy are written based on lasio. Lasio was made by Ken. He's from Australia. And what we can do with those things is pretty cool. I'm going to show you. Here I have this Jupyter notebook. Everything is loaded there, import. But what if you don't know how to install it before? Well, you will have to come here. If you're using Anaconda, I use Anaconda. Open your prompt. And here, pip install and the name of the library. I already have it installed, so I will not run it. Another thing that I would suggest, that I would recommend, especially if you're starting with this Python stuff, is that you create an environment. You have the base environment, but you can create as many environments as you want. And you can install different stuff on the different environments you have. For example, myself, I have one that is called base and one that is called geoscience, because that's where I install all these kind of libraries. If you're trying to install one called geopandas, I don't know why, but that's really difficult to install. This one, myself, I had a lot of troubles trying to install this. This is pretty cool if you're working with the spatial data. But it's hard to install it on the base one. So you have to create an environment. And how you create it? Well, this is the syntax. If you just enter this, it will start creating the environment. Once it's ready, you just type conda activate and the name of your environment. It's not created, so it's not running. But because I didn't run it. So that's the way you can install these libraries. Once you have them, they are gonna run. If you don't install them before, you're gonna get an error that says module blah 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 not found. That's gonna happen all the time unless you install it. And well, let's say that you install them, everything is running smoothly, and now you want to load a LAS file. I want to show you how to load multiple wells, multiple LAS. If you want to run just one, simple. Let me copy this, it's faster. And here, just write the root of your file, and that's gonna work. But sometimes, and especially when I'm doing, I have to load more than one. Sometimes it's even 400 LAS for what I'm doing. So this method right here has been working for me. This is using Welly. This is the same that is using lasio. And as you can see, in seconds, I just loaded these three files. If you want to move around the files, well, you will have to create a loop there for WINP. And then you start like typing whatever you want to see. If you want to see some specific, like the well name or the parameters or whatever, let's say. Ouch, that's not working that fast. But well, these wells are the ones that are already on the list of wells. And if you iterate over it, you will be able to find whatever the information you want. What I'm doing right now is that I'm extracting metadata from the wells. My company is building a database, so we need that information. That's using Welly. Now, if you want to use PetroPy, it's exactly the same. Well, just use ptr.log, and that's gonna run like this. And there you go. These are the files that are being loaded. If you want to see what information comes in the last well trial, there you go. Now, I hope you can see these B-shell, saturation, and porosity curves. Well, this happens because PetroPy has a file that is a curve alias. So what I did here is that I use the one that comes with the library, what I created, I added more curves. Why? Because I don't know in your countries, but here sometimes information is a little bit messy. So the curves in the last file, instead of having just SW or BShell, BSH, they have plenty of different names. So if I want to run an operation using the curves, I need to know what the name of the curve is. So it's easier for me to pass an alias and create a common curve name. For example, here I have BSH IR. Maybe the next well I'm going to load, it has a different name. Maybe it's BSH 2016. So what I do for those cases is I pass that alias, and PetroPy pass the alias automatically. And if they find that they have, if the alias finds something like this, automatically creates a copy of that curve with this name. That's pretty good if you are thinking on having all your data on a common name or something common, something that you can always remember. Yeah, I need all the curves of porosity, of density, or whatever. That alias is pretty good, and you can find that one on the folder where the library is installed. It's this one, curve alias. If you open it, it's just right here. It has the alias for the most common curve names according to different companies. So in case you have a last file and you have this kind of mnemonics, it will change the mnemonic. It will create a copy of that curve with this standardized name. That's pretty good because that's automatic and you can start like working with it without any problem.
So one question. So Welly and PetroPy are they have the same purpose, just loading the data and converting it into some sort of a Python class?
I didn't listen the last part. Sorry, Alejandro.
If
Could you repeat it?
Welly and PetroPy, they have the same purpose of loading the data and converting it into a Python class or a sort of.
Yeah. You can use both. You can use both or the three of them, even lasio, to load the data, and the data is converted to a data frame and also a dictionary. So you can work around. I'm going to show you that in a moment. So remember, I load 3 wells using Welly and 3 wells using PetroPy. Well, let's see the information and let's load those wells. As I told you, here on the Welly, I made P equals project. It's a class that they have on Welly. It groups a number of wells. So here I will just iterate around and you can plot. I'm plotting the last curves, the description, the unit value, and at the bottom, automatically I'm just plotting all the cubes in that well. That's pretty straightforward, no problems. You just plot whatever you need. In case you wanna change the colors of the cubes, you will have to pass a legend. You write on the legend the keys you want, what you want, and that's gonna change the color of the cubes. As you know, all the lasks, I have one here, are divided into different sections on the header. So in case you want to see that information, you will have to change this. If I have last curves, I see all the information of the curves. If I pass params, I see the parameters. If I have, I think it's well, all the information from the header of the well section is shown. If you want just one specific, you will have to type it more specifically because you just want that information. In my case, I'm using this to extract the data without having people loading the wells into any software or notepad and looking at the header and copying, pasting. This is an automatic process. I just select what I want and the data is extracted, and at the end I can save it on an Excel spreadsheet, and it takes seconds for a well, for a last. As I was telling Alejandro, all the information is passed into a data frame. That means you can create columns, you can sort it as you want, you can do all the operations and that you can do with a data frame. If you want to add a column that is, let's say, you have the permeability divided by something, you can do it. You just type it and the column is going to be created. But I'll show you that in a moment. Also, if you want to see a specific data, this is the curve that is the effective porosity. Here I can see the information. With this command, data, you can save that data into a variable if you want. Just do it like this, and it's gonna work. In case you want to use it for something else. If you want to see the minimum and maximum, you just write min, and the information is extracted and you can see it. If you want to see just what it is, summarize the information of the well, there you go, it's just W. What if I want to see information from just one curve? Well, there you go. That's pretty easy, pretty simple. And with PetroPy, it's the same procedure. Both are saved as a data frame, and in both, you can see all the information that you want. If you just want to extract min, max, and mean values of every curve for any statistical process you are running, you can do it. Also, if you want to do some data science, I think it's really cool that you can have this as a data frame, because then you can save it as a non-PRI, and that you can have it as part of your process on, let's say you want to predict a curve or something like that, you can use that information. It's pretty cool, it's pretty fast the way you can work with this. You can load 3, 4, 20 wells in 2 minutes, 3 minutes, something like that. You can modify the information. Here, what I'm doing is I'm copying it into a different data frame because I want to run an operation to them. I just want to multiply K4 times 0.1. And there you go. The column gets created, and you can export that to the last file with no problems. And as I told you, this is a data frame, and it's also a dictionary. You can delete it if you want, no problems. The curve is gone. If you want this data frame that we created here to be now the cube data on the last file, it's easy. Last set data, and now the information is there, and then you just save it as a new file, and you got it. If you want the cube data not as a last file, but you want it as CSV, it's possible too. Sure. Okay. This should be running. Okay. Sorry guys, I don't know what object data I have not sure. Okay. There you go. And this is what I was telling you about the cubes I created with PetroPy. This B-shell, saturation, porosity. This has a function called precondition. It's not necessary to run it because PetroPy will do it automatically once you load the last. This process of creating this is automatic, so this is not necessary to run it. I just have it there just for you guys to see it, that this is the way you can do it, but you have it already. So it's not necessary unless you create a new curve with a different name that you want to change that name using the alias. In that case, that could help because the last has already been loaded. The new cubes have been created, but then you made another curve that maybe is inside the alias with a different or more common name. You want to change it? That's possible. Well, that's now using all basically it's all what I've been telling you guys. This is something I'm doing. I'm using the porosity, the effective porosity, the B shell, and the water saturation as a way to calculate net pay. The customer, well, my company is working for a company, and they asked us to create the net pay on wells, unevaluated, wells that have evaluated petrophysical evaluations. So what I'm doing here is that I set up some cutoff. The B shell 0.15, effective porosity 0.01, water saturation 0.4, and using this function on PetroPy, that is log at pay flag, you can create that curve that is going to show only zeros and ones. 0 in the case the first, the second, or the third condition is not validated, it's going to be a 0. If all the three of them are okay, it's going to show 1. Only in the case all the three values match the requirements. And you can name it as the name you want, and you can extract it in the way you want it. Mainly I use a LAS file. And something I've seen people having troubles with is that when they are running the PetroPy, that is the examples. The examples run, well, once you modify that old Python version problem that PetroPy has, they want to load their own last files, but at the moment they want to plot it, they have problems with it. The problem there is that maybe you get a error name that says the cure blah 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 is not found. What you have to do in that case is that you go again to the folder where you install PetroPy, and you will find these templates. These are for multiple purposes. Let's say, let's open this one. Here are the names of the curves that are going to be plotted. Actually, the way PetroPy plots, I find it pretty good. So in case you don't have these curve names in your last file, what you have to do, guys, is to customize and make your own. Like this is the normal one, the one that comes with PetroPy. I made this one because I'm only using effective porosity, water saturation, permeability, net pay, and the different volumes, BShell, PM, Dolomite, and stuff like that. It's pretty simple. Just follow the example that you get on the templates. I suggest that if you're going to modify one, make a copy of it. In case something happens, you can always go back to the copy and have it ready. And this is the way you can plot your last files that you're loading that is not part of the example. Let's say you have a file that has the curves that do not appear on this template. You can modify that. Just check the values, make some trial and error, work with it, and it's gonna be running in seconds. Save it, rerun everything, and it's going to be working. And also, as part of everything, I don't know if you're familiar with Welly enough, and well, Matt Hall, Evan, Rob, they have made some pretty cool tutorials on the Welly documentation page, and this is based on it because I have a request from the company. The wells we have, the last files, they only have the MD cure. They didn't have TBD or TBD subsea cures. So what I'm doing here is I'm using Welly to load the file, and also I'm loading the survey. The survey has, the survey has the MD, the azimuth, the inclination, in some cases the TBD. Welly, what it's going to do is going to take those values and it's going to create a position log. And it's going to be added into the log. Well, not added into the into the Welly object that you create with the last. So what I do is once I load the survey, using the MD, I create the whole TBD column for all the data in the well. Using the Kelly bushing, I made the TBD into negative, then I added the Kelly bushing, and I have the TBD subsea. This is the simplest way to go around this. There are more sophisticated ways, because I think this one, Welly uses an interpolation based on the values, and is using the minimum curvature. And I know there's a couple of more algorithms or ways to do it, but this has worked so far for me. And well, here the only thing I need to add, for example, to this is a way to be loading all the KB for different wells, and that will be automatic for 500 wells, and it's gonna work with no problems. Also, when you add the survey, you can calculate trajectory, you can plot it as a plan on a map section, or you can see the deviation on 3D. Something about this 3D plot is that this curve that is from 1,000 to 4,000, that's not real. That's something that is making, because the well that I had doesn't have that information. So Welly is trying to calculate that. That's why it looks like that. The accurate or the best values comes from 5,000 to below. Okay, so those are some of the applications, and by using Welly you can create more complicated or more, not complicated, but the stuff that can give you more. Let me show you. This is a project my team and I made for Transfer 2020 hackathon. What we wanted to do here, guys, is to make a dashboard that could allow us to load LAS files, plot them, make cross plots. There's another version that is Michael is working on it. Is to pick tops and save them. So this is what we presented by the end of that hackathon. And well, when you are making something like this, you are not only using Python, you have to use HTML, a little bit of CSS. To be honest, it's something I want to learn to do because I have no idea. And I think these kind of dashboards are better than something you can get with proprietary software. There's 3-4 very famous dashboard softwares already on the market, but I think that the advantage of doing it with Python, doing it by yourself, is that you can do it as you want, giving it the interactivity you want. And remember, this is open source, so it's a little bit kind of free to design, to make it. Once you want to take it to the web, well, that's going to be a different story, because maybe there you will have to pay a little bit for storage and to add security, blah, 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 blah. But the main whole idea, this is something what that was made in a week. We were like 6 people working on it. Not all of us were like experts on working with LAS files on Python and stuff like that. That's something that also I would like to leave as a message. Don't be afraid of trying, don't be afraid of asking questions. I've been texting Kent from Lasio every time I have a problem and I cannot find the solution, the documentation, and at the end, that problem sometimes creates an issue and it's something that they have to fix. So that's the best way to go around. Go and ask questions. There's a community called Software Underground. I don't know if you know it. Most of the people that wrote these libraries is there. Matt, Fabian, Rob, Kent, the guys from Liz, Jürgen, they are there. All of them are there. If you send them a message, if you try to talk to them and tell them, I have an issue with this, from time to time, I cannot promise you they are going to answer to you within seconds or minutes, but well, in my case, every time I have asked something, I have received an answer, like either go around this or let me check that because that's an issue, that's an error, that's something that should not be happening. So by now, that's what I wanted to show you guys. I hope this is something that can help you. I am going to upload these notebooks into a GitHub account, give Diana the link, and in case, well, you want it, just reach Diana or either me on social media, Julio Rodriguez Luna. I think that's how I appear on that famous social media that starts with link. Okay. I don't know if you have any question, we can talk about it.
a few minutes for questions, so feel free to type or unmute. Probably will be faster unmuting. In the meantime, I have a question. So what is the main difference between Welly and lasio? Both are packages for Python, but what you will call is the main difference between these two?
I would say Welly, they included more stuff than lasio. For example, Welly has a function that in case you're loading 10, 20 wells from a project and you want to see the quality of those wells, you can set up some flags and automatically analyze those wells. And it will show you in a HTML table the results of that quality control. That's something lasio doesn't have. Also for lasio, the mobile loading, I think it's better the one the project has. Project on Welly. If you're loading multiple wells, I think Welly is better for it because you can make more use of project. On project, if you want, you can see all the information from your wells and see how many cubes they have, what are the name of the cubes. For lasio, that's not possible. Both run. I mean, Welly runs above lasio, so you will use both at the end.
Yeah, and I have seen probably is a recommendation, don't discard one, right? Some packages, they have some of functions that are going to work and complementary with others or things like that. It's definitely not saying like just use one because they have many advantages to use them together. Luis has a question. Thank you, Julio, for your presentation. Could you share the GitHub link in the Slack group? So I don't know, Julio, are you in the Slack group for the PG community?
No.
Okay, so let's do that. I will invite you and you will join there and probably we can share the material there. Yeah, by the Slack channel for the Python PG community, if I'm not wrong, it's called.
Yes.
Python PG community, yes. So we will share the information and by them. Somebody else have a question, comment?
Julio, can you show again the...
So just a little bit, we were trying, I was trying to run the PetroPy package. Mm-hmm. And thanks to Julio, we found like a couple things that are not updated, but they should be running correctly. The good thing about PetroPy is that they have the alias file that you can try and to see if it's running okay. I think that I appreciate that because for me it was like, I don't want to start with my own data. I want to first make sure that it's running how it should be. There was a couple things, like for example, in the last template, the tops weren't showing as they should. And it's something that I haven't been able to kind of correct or to see what is going on in that way. Probably it's the XML now, as you mentioned. So it will be worth it for me to check that.
For when you're loading the tops on PetroPy, I suggest the CSV file that you pass into PetroPy, copy the column name on the original. Now, if you don't have it like that way, it doesn't work. That's one thing. And also, you just need to write the mnemonics of the formations you have. You don't need to keep using the same mnemonics that the example has. And also, there is a section where you have to change the mnemonics. It's for the viewer, actually. Okay. On that section, you have to change the mnemonics to the ones you have. What I do, in order not to complicate my life a lot with that part, is that I load the tops. I make sure the tops are loading, and in that section of the viewer where you have to assign a top and base, I just tell the program that choose the first and the last top in the file for that specific well. Also, on the tops, you have to give a reference to the well, and the well and the tops file, they have to be connected by the UWI.
Mm-hmm. Yeah.
If they are not the same, you're not gonna load anything. Yeah.
That is good. Okay. That is definitely, few things that definitely is they are there, they are not there, but we need to cache, and so it's good. Thank you, Julio. Somebody else? I hear somebody that was talking or asking.
Yes.
Felix? Yeah. Go ahead.
Thank you. Oh, well, Julio, how are you doing? Thanks for your presentation. I have a couple of questions. First, you mentioned that this dashboard for the user interface was developed for a hackathon.
Mm-hmm.
Well, could you tell us a little bit more about this hackathon? Where was organized? Who were the participants?
Well, this was made by the Software Underground community on
Software
June.
Underground community.
Yep. Have you heard about it? Felix?
Okay.
Have you heard about that community?
No, it's the first time that I hear about it.
I'll give you the link. But okay, so that was organized in June, and there were people from all around the world.
Okay.
From Latin America, there were just like 3-4 people. I remember one person from Colombia, me, I was the only one from Mexico, and I think there was another person from Bolivia or Peru. And mainly it was people from Europe, USA. That was like the first virtual event of this type, because the previous one was in France last year. And this one, well, the circumstances changed a little bit of things. That was made online. It was virtual. It was a series of tutorials on Python, on different stuff, and also a week hackathon. There were like different projects. You can also find this community on Slack. If you follow the link I gave you, you can find things there. And well, it's a pretty good place to start looking, because there's a lot of things being shared over there. It might be a little bit difficult at the beginning. When I just entered, I think it was like a year ago or something like that. I found it a little bit hardcore. You know what I mean? Like, I think the guys that are writing these libraries are here discussing the stuff that I don't understand. So it was a little bit scary at the beginning, but then you start like working a little bit more, seeing that the community shares stuff and is eager to help people. So that's another place. I mean, PhD community is also good, and there's also this software underground. I mean, there's community that's pretty cool. But there are communities.
They have also the YouTube channel when they have like some videos of these tutorials. So I put the link also in the chat window for the software underground platform. Mm-hmm.
So these people from Software Underground, they are supporting this. Please tell me if I am wrong. But what I understand is that they are supporting these libraries like PetroPy or Welly, or it's not like that.
Yeah, some of the coders that have been written these libraries, they are there. It's part of the community, and there's plenty more stuff there. If you are into seismic, there's also libraries for seismic, for the spatial data. There's many things there to go and check and learn.
Yeah. Okay. Nice. So if we want to join this group, we have to go to the Slack group.
Yeah,
Right.
Just follow the Slack group as for any other community on Slack, and you get automatically on the general channel, and from there you can start like moving around.
Okay. Cool.
Yeah, I think that recently was created one for Welly, right? Like a channel for only Welly.
There's a channel called Welly. There's a channel called Python. There's a channel called Open Geoscience. So there's like plenty of stuff. Diana.
Yeah.
This is the part I was telling you. I have a mess here. Okay, yeah. I kept the example WFMP top. So here I made a list of the tops, and I just have the first and the last. So I'm not worried anymore about which. Yeah, and at the end it loads everything. I mean, if you have something specific to if you want to check something more specific, well, you can just write here the name of the top.
The specific name. Mm-hmm.
Yeah, but it works. Well, that has.
How do you set the depth of a top?
That's already on the tops file.
It's a CSV file with the tops.
Like this. It's a file like this that has I was telling you this, the UWI, and has all the mnemonics for the formations and the tops for it.
I see. And
that's
when you apply the function that you applied before, so how can you restrict it to a particular formation?
What you can do is here, instead of having 0, you can have log.tops bracket the name of the formation. As it comes in I have the example here.
It will be like Woodford or Eagleford or the actual name.
Here.
Okay.
If you have, for example, I have here on this tops file, I have all these formations, but I only want the Kimmer and I want the Eocene. I will write here Eocene and I will write here Kimmer.
I see.
Okay. Replace this one. And that's the best way to go around that.
I see.
Yeah, something that PetroPy has, and I kind of don't like it a lot, is that you necessarily need the tops to work with it.
Yeah, and that's where I got confused, because you're talking at the beginning of Welly, and then you're talking about PetroPy. I thought that we were still in Welly.
Yeah, sorry guys. Yeah, Welly doesn't require any tops, because basically what you do in Welly is you load the file, you can have a data frame, you can load the survey, you can plot it, and that's basically what it does. PetroPy, as is more like into petrophysics, it requires the tops for running any petrophysical operation that it has been coded. You necessarily need the tops to run on it. And if you don't have it, that's a little bit difficult.
Oh, okay. So what you're saying is that with PetroPy, you actually have functions that are petrophysical functions in PetroPy.
Yeah.
Okay, and you constrain you have to apply the function to within a particular top bottom formation.
Yeah,
right.
That's a requirement. Mm-hmm.
That's a requirement for PetroPy. Right. If you don't have it, that makes things a little bit more complicated. But yeah, it's more into petrophysics. You can run a complete evaluation of PetroPy within seconds, but in order to run it the best way, you have to modify these values on fluid properties parameters and multi-mineral parameters. because those are the parameters that is going to load anytime you run it. But those parameters are for example. So maybe in your well is going to be something different. So you modify those parameters and then you run the rest.
Okay. And when you show the deviation survey, the well path, you have a separate file for the deviation survey.
Yeah. Yeah, because typically you have the last file and you have the surveys.
Right.
On an Excel file or a CSV file, and you have to load it.
Okay.
Once you load it, it's going to be part of the Welly object. That is the last information that you loaded, and it calculates the position load.
Okay. Then one more question on my side is: do you have any example applying neural networks on one or multiple wells, where you do your interpretation on few wells, and the neural network learns from that interpretation and apply it to the rest of the well, for instance, for facies classification?
The only one I have run is similar to the one Brendan Hall published on 2016. It's published on the SEG. If you want to, yeah, if you want to follow, if you want to find it, you can find it on the tutorial GitHub of SEG. Brendan Hall made a very good. Well, he made a good example of using machine learning for facies classification, and then there was a worldwide contest to improve what he made. So if you Google that, you will find the code made by Brendan and the code made by the rest of the teams. So you can find a lot of things there. What I've done once was I was trying to make some correlation panels, but I was using, I don't know if you're familiar with Shazam. This app to find music. Sounds. Yeah, you play a little bit of the sound and it finds the sound that you were listening based on the frequency analysis. It finds like the matches. So we were doing the same, trying to find the correlation between a group of wells based on a section and the best way they correlate to each other and rank them. That was for a hackathon also. And if I find I just worked that on a weekend and then I stopped working on it. But if I find the code, I can share it with you guys. I mean, that's something that it was pretty cool. And the school had a contest on that actually last like 3 months ago, creating wells based on dynamic time analysis or something like that.
Okay, we have over just 7 minutes before the hour. I don't know if anyone else wants to introduce yourself, share what you are working on it, or why you are interested, or the type of projects that you have. Feel free to share. The idea
I have a question.
Yeah, of course.
Hey, Julio, sorry I joined late, but I was wondering how difficult it is to modify, like, let's say if I want to use PetroPy and I don't have resistivity curve, I want to put something else, let's say total gas. Would it be difficult to modify the code and plot the data that you have?
Well, if you know what you are trying to make, I don't think it's not going to be that difficult. I have modified a little bit of the lasio code because some things I want them in a different way. What I do is I always have a backup of well, you can always reinstall in case you mess up with the things. But yeah, you can modify it, and even if you modify something and you think it's pretty good and you want to share it, you can always fork the repository of Kent That is the guy who wrote it. And if he likes it, well, that could be all part of lasio now. That's the way some stuff has been done. Somebody modifies the code, and there are changes.
And one more thing, it seems like Welly is much easier. So, is there a way to fill the curves with some color, like in PetroPy? Fill the curves with color in Welly?
Yeah.
It's a field thing.
It's not in the same way that PetroPy. I mean, it doesn't look like this. You can just change the color and fill the curves with any CMap palette. But yeah, I mean, if you construct your viewer the same way PetroPy did, yeah, you can also do it in Welly. But it's not like a function that is already there. It's something you have to make yourself, that part.
Okay.
So it won't be taken care by the XML, where I am giving the parameters of the template, and I say, okay, this curve has to be filled with this color.
Yeah.
It will be from the XML.
Like this.
I will find that probably will be the easier way to do it. If you want a template that is going to look in that way, right?
Yep. Yeah, you will have to make the function for plotting the different curves you want, so you can use it anytime you want.
Somebody else?
On the Welly tutorial, there's I think there's a way to do it, to plot and to fill the curve with a color palette. You should check it, and I think, well, that's gonna help a lot.
I'm pretty sure because it's kind of like a common function. Fill to the left, fill to the right, or fill between two curves is probably something that is already there. So.
Yeah, at the end is matplotlib, so you can work with the parameters on the same way you can work with any plot on that library. So there's multiple possibilities on it.
Good. Somebody else? Don't be shy.
Also, guys, if you are looking for data, well, there's the ball field from Equinor. There's the Poseidon data, and I think there's also a chance to get some data from the Oil and Gas Authority on UK. So there's data there to try things, to use it, to test what you're doing in case you don't have like data from a company or something like that. You can go and look on those things. There's multiple possibilities around there.
Okay, someone else? Okay, so currently there is the PetroPy package, and that hasn't been updated from 2018 or something like that. What do you think that we should do it? Like, what do you think that we should update to? It will be good to keep the workflow that as is and add probably more functions for, I don't know, unconventionals or something like that. Will be something good to do, or what do you think?
I think PetroPy has lots of potential. Unfortunately, the guy who wrote it, I was